Okay, so what is the definition of computer system or computer? Can you please read?
Electronic device. An electronic device is storing and processing data, typically in binary form, according to the instructions given to it in a variable program.
Okay, so can you elaborate on this? What is the meaning of this?
Basically, I mean, we as you know the user has got to input the raw data into the computer through the keyboard and everything else, and the processors and everything else will take that raw data and well process it into usable format.
Yes.
Output it as usable format.
Okay, so let me go to the next screen. It's all right. So this is the diagram. So you need four things. One is user input, one is the program, another computer process it, takes the user input and the program and generate the output. Okay, let me give you an example. So suppose you are writing on Microsoft Word. So Word is the program. Okay, Microsoft Word. Microsoft Word is a program. Okay, what is the you are right on this?
Yes.
Is the input from the keyboard. Using keyboard, you provide the input, and whatever you press it, like suppose you give the instruction to make it bold, so you make that particular word bold. That's your output. Okay, so a computer has three things. One is the input. It takes some input from some and then it processes it using some program and generates some output. Okay, that's the basically a and this device, computer, should be electronic device. Okay, it's a electronic device that takes a user input, a program, our instructions how to deal with this input and generate some output. Okay.
Yes, sir.
Yes. So let me go to the next slide. Okay. So to take this input, so to take this input, you need some input devices like keyboard.
Yes.
Otherwise, how you provide the instruction, some input to the computer, or your mouse, or a touchpad, like in your mobile screen. So these are some input devices using which you provide the input to your computer system. And then you also need some program like your browser like Chrome, or like Zoom, what you currently using. So these are the programs or instructions to deal with the input, and then it generates some output. So at least you need three things. Taking some input, you need the input device and the program.
Input.
Yes. And then
and the output.
Yeah, some output devices like your monitor, computer screen, or printer.
Monitor, speakers, or
Yeah. Okay, and these sometimes you need this program to be stored somewhere on the computer system. So for that you need a storage system so that you can permanently store the thing. So let me move to the slide again and go to the definition. So it's an electronic device for storing and processing data, typically in a binary form, according to the instructions given to in a variable program. So what is the meaning of this variable program?
According to instructions given to it in a variable program.
Yes.
Uh, the program is basically the shucks, I didn't remember this. Give me a minute, sir. I can't remember too good.
You can't remember? Okay. Your computer is not just using one program, and the single program is neither fixed. Yes or no? Right? You are using Microsoft Word,
No.
or PowerPoint, or your Zoom app, or some browser, anything. Okay? Get the point?
Yes, sir.
Yes. The computer is not fixed for single program. You have multiple programs, and so that's the point. That's the main point here. Sorry. That's the point on the slide. Structure this thing. Instruction given to in a variable program. It's not a single program. You can change the program. You write a new program. Okay?
Oh, yes, sir.
So next, this is the history of the computer program. I'm not going deep in this. Earlier, these are mechanical systems, and then it moved to the analog computers, and currently we are using the digital computers. And these are the, this is the ENIAC, this is the first digital computers. You can go to the slides, and if you want to, can you visit the links? These are the links. You can go and see the detailed things here.
Yes.
So earlier is
right.
Mechanical computers, then we move to the analog computers, and currently we are using the digital computer. So what is the meaning of digital computer, Mark?
The digital computer, unlike these other computers, digital computer would basically mean the information would move faster and it would be more lightweight and it wouldn't take up as much space.
Yes, that's true. That's true. So the main point is this: in your digital computer, all the computation is done between two things, 0 and 1. That is, we call it the binary system. Are you remember this thing from the classes? I give the example of switch, on or off.
On or off, true or false.
Yes, true or false. So this is the binary system, and this is the core of the digital computers. It's just operate on two things, 0 or 1, or on or off. Anything that's just between the two stages is a good thing, is a good candidate for the binary system. Therefore, I take this example from the switch that has only two states, on or off. You can't find any other stage in a switch. Your switch is either an on stage or an off stage. The switch is a binary system. Are there any other stage in a switch?
No, sir. It's because it only works with zeros and ones.
Yes, this switch is only any switch. If you try to find a switch, the switch is in only two stages, either on stage or off stage. You can't find any other stage. So that is the good candidate for a binary system. Let me move to the other things. So here, these all the devices what I am showing you. In the first generation, we use the vacuum tube. So it's the large, and one vacuum tube is store only one thing. So let me go here. So what are these devices? Any device I am showing you is just in only two stages, either on stage or off stage. So first there is a vacuum tube.
On or off.
Yes. So this vacuum tube has only two stages, either in on stage or in off stage. It's just a device like a switch, but it's electronic. But the size of the vacuum tube is very large. It's like a bulb. Okay, so to store one bit, you can on or off just to store one thing, one bit. To store one bit, we have been require this much size of the device in the first generation. So the computer system in the first generation are large, its size is large, and its speed is slow. Then we move in the second generation to the transistor, and the transistors are much smaller in comparison to the vacuum tube, and its speed is also high. Then we move to the third generation to the integrated chips. Integrated chips has a millions of transistors stored in a chip. So million of transistor means million of bits stored in a single. So million of transistor means million of bits are stored in such a device, small device. Okay.
Yes, sir.
Then we move in the fourth generation where we have the microprocessor. So this is the whole computing system is just put available in a single chip. That is the fourth generation. So devices become smaller and smaller, and speed is increasing. And currently we are in the fifth generation where the AI is dominating factor. Okay, AI system, artificial intelligence system.
Yes, sir.
Okay, so this is the history of the computer. As we move from the first generation to the fifth generation, size is decreasing. Devices become smaller and smaller, but the speed increases. Okay.
And the speed increases.
Okay. What is the meaning of speed increases? How you measure the speed?
The speed increases mean it could process information more faster.
Exactly. So if your computer, you may see this device has 2.3 gigahertz processor. You ever see or heard about this thing? Like in mobile devices, 1.8 gigahertz. What is the meaning of that?
Means how fast it could process the data.
That's true. That's true. But what is the meaning? What is the meaning of this 2.3 gigahertz?
That I do not know.
Okay. So it means 2.3 multiplied by this much, 90, 1 after 90, 3 and 3. If you calculate it, it's become 2, 3. What is this amount?
23, I think is a million. Billion?
Yes. So these much instructions per second. So this is the meaning. So when you see some your mobile devices or computer devices, and when you see your processor has 2.3 gigahertz processor, the meaning is if you say 2.3 gigahertz means 1 after then 9 zeros. Getting? So after 1, I put this 90, 336, 390. Okay, and you just multiply it.
9 zeros.
Okay, this much instructions per second. Each and every second, a computer can process this much instructions, and that is a large number of instructions. So this is your computer speed today. So as the devices become smaller, it minimum power requires, and its speed is increasing, size is also decreasing. So this is the things moving from the past to the current, or first generation to the fifth generation. Clear?
Yes, sir.
So please remember this processor speed. What is the meaning of this processor speed? Wherever you see your processor, I will go in detail in the what is the meaning of core. You heard about octa-core, hexa-core, dual core, so many things. So when we discuss about the CPU, then we again move to the core thing. But I'm just giving the brief idea about what is this meaning of this speed is increasing. So its speed is increasing like this. Now we can process 23 billion instructions per second. Okay.
Yeah.
So now, what are the components of the computer? So we already discussed this thing.
Input,
Yes. So we need an input device like keyboard, mouse, touch screen. We need some output devices like your display, printers, speakers, some processing device like CPU or GPU, and some memory devices like RAM, disk, or SSD cards. Okay. When we discuss about the memory card, we move again to this in detail.
Right.
What is this RAM or HDD or disk or SSD? Okay. For this exam point of view, this is not the important figure for you, but this is your processor system. This thing is your processors. Okay, so your processor CPU, processor or CPU, processor or central processing unit. That is the full name of the processor, but we generally call it the processor. So processors, and then you have the main memory or RAM. This is your RAM. Okay, so these are connected through the I/O bridge.
Yes.
And then we have this keyboard and mouse. This is display, your monitor, and this is your disk. So please remember this diagram. The only important thing is this. Please see here. This CPU is connected to your RAM using this is directly connected using the I/O bridge. That is the faster system. Okay.
Input output.
And your input output devices like your keyboard or mouse or display or disk is connected to the I/O bus. These three devices are connected through the I/O bus. So data goes through this path. It goes taking from the graphics adapter. Take for the example your keyboard. So from the keyboard input comes, move to the I/O bus to I/O bridge, and then move to the CPU. Getting the point? But from the main memory, directly move to the CPU. Therefore, your RAM is faster in comparison to your disk or keyboard or mouse. Okay. Again, when we discuss about this memory system, we again come to the processor. We again come to this part. Okay. Any questions up to this point?
No, sir. Straightforward.
Straightforward. Good. Okay, so we reached to the end of the slide. What is the difference between analog and digital computer?
The difference basically with the analog, they got few, digital. Yeah, the analog isn't as fast as digital because digital computer got a lot of processing power, not to mention it's also faster, especially when it comes to the like with speed, as you explained just now with the 2.3 gigahertz. When you multiply it by the number, how we could do 23 billion instructions per second is way faster than the analog in general. That's why everybody and everything nowadays is use a digital computer, not the analog, because the information could easily move and process more faster.
That's true. Yes. Okay. Next question. What are the various applications of computer?
The application as in the programs you use, or
this question. What are the various applications of computer system or computer?
Various applications. What are the various applications? Would that be the programs we use or something else?
No, my question is where you are using the computer system. So if you go, wherever you are using in your offices or normal office works, or specialized in the field of medical, railway reservations, or flight reservations. You can go anywhere, any place you can find the computers in the medical, in the education fields, in medical systems, any offices, all the e-commerce thing, internet of things, everywhere the computer is you use everywhere. That's the point. That's the questions. Okay.
Oh.
Yes. Any doubt?
Well, this second question, I would gotta read up on it some more, but the various components of computer system, I could answer that, because it's basically the keyboard, mouse, monitor, speakers, printers, and it goes on. The difference between the RAM and HDD is that the RAM is random access memory, which in it's only there while the computer is on, and once it shuts off, it's the information is gone. But the HDD, which is the hard disk drive, the information is stored there. Even when the computer comes off, you could turn the computer back on and the information is still there. Yeah. Adapter and controller devices.
This is at later point of the time. Okay. So means maybe tomorrow or day after tomorrow we discuss these two things. What are the various components of the CPU and what is the difference between adapter and controller devices? So these are the things we discuss on the next session. Okay. All right, sir. Okay. So, Mark, today we stop at this point. Tomorrow at the same time, 9 a.m. We this already I shared the link, and we will be there next session. That is the CPU. Okay, so please go through the slides and start. All right, sir. Okay, I'm not taking the quiz today yet, but from the tomorrow onwards, we take the quiz in the class only, in the session only. So we give a chance to answer the quiz in the class. Okay. All right, sir. I will make sure to do the quiz and read up for some from some of these slides. Okay. And if you have any doubt in between, please WhatsApp me so that I can take those questions in the session. Okay. All right, sir. No problem. Okay. So I stop here today, and for the tomorrow, I will share you the detail. Okay. All right. Good, sir. No problem. Okay. Bye. All right. Bye-bye.